Hello and welcome to this repair tutorial, and today we're going to look at a QTX Pro240 amplifier. So before we get into the repair, just general overview of specifications. So power output is 60 watts RMS, and that delivers it into 2 times 4 ohm speaker loads, but that will reduce down to 40 watts per channel if you're connecting 8 ohm speakers. And where you get the Pro240 from is that the manufacturer is referring to max power output of 120 watts times 2 into a 4 ohm speaker load. Now this power amplifier or OD amplifier does not support a bridge mode, which is very common with high-end power amplifiers. Here you do not have the bridge capability, and also as well it is a very entry-level power amplifier. Typically you will also see the same kind of board design or circuit design in other amplifiers using the same type of chassis, and it's more of a generic type OEM amplifier. And then for frequency response, maximum goes up to 20 kilohertz, and then total harmonic distortion comes in at 0.5%, and then signal to noise ratio at 98 dB. And then when you look from the rear for your connections, you have 2 RCA socket inputs, or alternatively you can use 2 times 6.3 millimeter jack plugs coming into there. And then the speakers for the connection, you have binding posts, but the binding posts can also accept 4mm banana jacks if required. And then from the front, the power switch is illuminated, so here it's blue color. And then you also have power or level indicators for left and right, so as you increase the signal using the volume control for the left and right channel, depending on the audio signal level, you'll see that the LEDs will then illuminate in sequence. And then, as I said, it's a 2U dimension for 19-inch rack, and the amplifier does incorporate a cooling fan. So for studio work, often cooling fans are not desirable because of the background noise, and it's really just a conventional cooling fan, 12 volts, that you would find in a PC or maybe some form of power supply. And then height, it's 88, and then width is 480 with the overall depth of 240 millimeters, and the weight of the amplifier comes in at 5.2 kilograms overall. So really, what was the sort of the issue with the amplifier when it came into the workshop? Well, the first thing was that the customer reported that they sort of took the lid off and had a look internally, and then what they quickly noticed was that there was 2 fuses which were blown on the right channel, which is like where the power input comes in, and there's also a secondary fuse towards the back of that part of the circuit, and they just clip into these fuse holders, 20mm 50D fuse holders, and that fuse is also blown. And both of these fuses are T2 amp or time delay or thermal delay 2 amp fuses. Now, quite rightly, what the customer did was they went off and bought some replacement fuses exactly the same rating, which is the correct thing to do. You never want to uprate them and then just replace the fuses, but on power up again the fuses failed. So of course that would indicate that there is a component failure on the amp. So normal practice, after visual inspection, what you can see, and I've sort of shown it also in the video as well, you can see that there is a resistor which is burnt out on the respective right channel. And what you have with these amplifiers, you don't have a circuit diagram available. If you did a sort of Google search, you don't come up with anything which links to these amplifiers. And I've literally repaired hundreds of these amps over the time. But what it does have is, when you look at the board layout, on the top of the silk screen, they put the value of the component. So here the burnt out resistor, once you'd removed it, you would see 220. So it indicates to you that it's a 220 ohm resistor that has gone open circuit or burnt out. And that's the same for all of the components. The small signal transistors and capacitors, if you remove them, it has the part number written on the board. So it does make it sort of fault finding super easy for maybe people who are doing this for the first time, but it does sort of remove the guesswork to sort of say, well, you know, what's the value of that burnt out resistor? You could refer to the working channel, but maybe if it was in a part of the circuit where you didn't have a duplication, then it may be difficult to determine. So that's what you have. And then The thing to do, of course, is replace the fuses. But I would also say, as well as I have on other tutorials, just squeeze in the end caps where the fuse is connecting to the fuse holders. Often what you'll find is that they spring open slightly and they can become loose. And even like intermittent loss of sound on these types of amplifiers, which doesn't incorporate any form of speaker protection system, you can sometimes find just loose fuse holders. So just take care of that. Say just a small pair of long nose pliers, just squeezing the ends, and then the fuses snap in, very, very tightly. So you power this up, of course, via the dim bulb tester, and I'll put a link into the video repair description just so you can refer back to it. But because I'm so familiar with these amplifiers, the first thing that I'm going to check is the audio output transistors, which are bolted onto the heatsink. And then these transistors here are tip 41 and tip 42. So that's why when you sort of look at the specifications, you have to sort of, just take it in mind that, this is not a super high powered amplifier. It just has, a couple of discrete output transistors to deliver the power to the outputs. But when these amplifiers fail, remember, if the fuse protection doesn't blow, you could have high DC up to rail potential delivered through to the speaker coil. So whenever you undertake any kind of repair like this, just check with the customer before they receive it back to just verify, look, can you check your speaker, make sure that it wasn't damaged when the amplifier failed. So really quite a straightforward repair from a component point of view. So replacement of the tip output transistors, and then there's also new heatsink compound which was applied, and the 220 ohm resistor was also replaced. Now, rather than just power up the amplifier and just check if the dim bulb works, the next course of action, which I would always advise people to do, is just to spend extra time and just verify that the resistors in, for example, the emitter circuit of the output transistors have not gone open circuit, or any of the smaller signal transistors have maybe failed short circuit, or there's another issue. It takes a few minutes, but what it will do is it will just give you the confidence then that when you then apply power, in most cases you should find that there's no other underlying issue, and there wasn't here. The reason why I mention things like the emitter resistors, because they're very low ohmage, like 0.22 ohms, it's very easy for them to go open circuit, but you have no visual indication at all. So just verify that then with your meter. And then also as well, when you are replacing the output tip transistors, just make sure that the insulation mica washer is good. The insulation plastic washer, where the screw goes through, is in no way damaged, and that you have isolation between the tab of the transistor back to the heatsink. And as I said, there was no sort of issue here. What I did find was when I removed the circuit board, and it's just held in place with these fixing nuts and then the 4 screws. When the board was turned over, one of the leads which goes back to the right speaker, there was almost as if like a component lead had sort of broke through, which may actually have been, the issue of why it failed. Sometimes you can find this during manufacture. As the board's screwed down, the components leads literally push through these leads which are underneath. They're not sort of routed through to avoid that. So really, to make that repair, no need to replace the complete wire. So what I use here is what we call SCL heat shrink, which has like a glue inside of it. And then just to remove the wire, slide on the heat shrink sleeve, and then you just use heat then just so it bonds to the wire connection, and that was fine. And then the next sort of part of the repair was just to remove, as I'm showing here, this fan. So this is the 12 volt fan, commonly found in switch mode power supplies or computer power supplies, and from it's a sort of bearingless fan. It wasn't noisy in operation, but there was quite a lot of sort of residual dust on there, so that was all cleared off. And then once the fan was reinstalled, my attention then was paid to the volume control potentiometers, which are used for the left and right channel. And then what I'm showing here in the video is just the board removed, and you're looking from underneath. And what I want to do, and what I'd advise you to do, is often what you'll find is you get dust build-up, and it could be brought in via the cooling fan or just through the vent grills at the front. And always spray into there some high quality switch cleaner or contact cleaner here we use De-Oxit, and then just rotate backwards and forwards those volume control potentiometers multiple times. And what you'll find is that you're rewarded then with a very clean operation. You shouldn't hear any sort of loss of sound as you make the adjustment, or any popping or crackling, which normally tells you that you have issues with dirt or maybe contamination onto the carbon tracks. And then once that was done, of course, power up the amplifier initially under the dim bulb, and then no issue. And then after that, power up the amplifier under full mains power. And there's no adjustment to make on the amplifier board. It's already set via the resistors and the circuit. But what I would always advise you to do is just to make sure that you don't have any sort of high DC offset. So here the amplifier was checked, just measuring across the rear terminals, and you were kind of, a few millivolts here and there. As part of the repair as well, it's always advisable for this make of amplifier to check another couple of things. The first one is that you have this small circuit board at the rear where you bring in your jack connectors or RCA connectors. Just remove the locking nuts from the rear and 2 fixing screws, and what you'll often find is that there's just some dry joints or breaking on the joints because of the mechanical stress. Just reflow them. Check also the speaker connection board as well, just make sure that there's no dry joints there, and just verify the sort of the locking nuts are all tight. And that's the same for the main amp board and also for the signal board at the front. And then the other thing that you can sometimes find is that the toroidal transformer fixing bolt becomes loose, and literally you can kind of move it around a bit. So just verify that that's okay, and then just lock it down, just with a couple of adjustable spanners. Always advise, you want that clamp, top clamp and locking nut just to be firm, but whatever you do, you don't want to over tighten them, because if you do, you could maybe crack some of the enamel on the insulation wire for the toroidal, and you don't want to be doing that. All right, so sort of last aspect of this, once it had gone through a full functional test, was just to do a cosmetic clean of the amplifier, and the customer, it's sort of maintained, it kept this amplifier in really good condition. It didn't sort of require any sort of extensive cleaning or sort of maybe replacement rubber feet on the bottom or anything like that, and all was good. All right, so that sort of brings us to the end of this repair tutorial. So I appreciate you stopping by and listening. And if you need any help or support with any repair, by all means contact Audio Amplifier Servicing at AOL.com. All right, until the next time, cheers, bye-bye.